Hi dears, good morning all of you. And in the last class we have discussed about clinical thermometers, right? So now we are going to discuss about the laboratory thermometer. Okay. So we have to find what are the difference between clinical thermometer and laboratory thermometer, how it differs from clinical thermometer, right? So, hope you understand how to measure the temperature using a clinical thermometer, right? So, now we are going to see how the laboratory thermometers work or how we can measure the heat temperature using laboratory thermometer. Okay. So, here in your textbooks, it is given the figure of a laboratory thermometer, right? So, look into that. The figure 4.4 is a laboratory thermometer, right? So, it is somewhat long, right? The length of this thermometer is somewhat uh, greater than that of clinical thermometer, right? And you can see what is given here. How do we measure the temperature of other object? That means we use clinical thermometer to measure the temperature of our body. Body temperature, how to measure body temperature using a clinical thermometer, right? But we cannot use clinical thermometer to measure the temperature of something but a boiling water or something what is something hot object, right? We cannot use clinical thermometer to measure the temperature of other hot objects. Okay. So for this purpose, there are other thermometers. One such thermometer is known as laboratory thermometer. Okay. So I will find or I will search in your labs if there is any thermometer is there. I will show you the next class. Okay. So just understand what is a laboratory thermometer and this is somewhat different from that of our clinical thermometer. Okay. So different thermometers are used for different purposes. The maximum and minimum temperatures of the previous day reported in weather reports are measured by a thermometer called the maximum minimum thermometer. Okay, so you can see or you can hear in newses that are temperatures or the weather reports says that the temperature is somewhat 37 degrees Celsius the last day or now it is what 42 degree like that, right? So this is only a rough uh, numbers, right? Actually you can see what are the weather conditions, what is the temperature or humidity like that. Okay, so to measure this temperature or weather temperature, what a maximum minimum thermometer is used for that purpose, right? So different thermometers are available and for different purposes they use different thermometers. Okay, so we have to find or we have to study about laboratory thermometer. So look at it carefully and note the height and the lowest temperature it can measure. The range of laboratory thermometer is generally from minus 10 degree to 110 degree. Okay, so how the clinical thermometer measures? Yeah, it's ranges from where to where. Yeah, it is given that it is from 34 degree to 35 to 44 or 35 to 42 like that. Okay, so that is a small range. Okay, so clinical thermometer it needs that much small range. Okay, so our body temperature is around 37 degree. Human body temperature is around 37 degree, right? So if we get illness or if we fell down with fever, it will rises up to a certain limit, right? So clinical thermometer needs only that much range, right? 35 to 42 only. But laboratory thermometers have a range of minus 10 degrees Celsius to minus 10 degrees Celsius to 110 degree Celsius. This is not negative sign. This is minus 10 degree to 110 degree centigrade or degree Celsius. Okay. So, also, as you did in the case of clinical thermometer, find out how much a small division on this thermometer reads. You would need this information to read the thermometer correctly. So, we already know if there is, suppose this is the thermometer tube and we know inside that a mercury thread will be there, and here we have scales, right? So suppose if you know this is 11 degree and this is 12 degree, right? We know this is 11 and this is 12, and in between these 11 and 12 maybe there are 10 lines, 10 small lines, or maybe some thermometers have 5 small lines in between these two large lines, right? So what will be the one small division, the value of one small division? If there is 10 lines, what will be the value of one small division? Yeah, it will be 0.1 degree Celsius, right? And if there is 5 small divisions in between the two large divisions, then what will be? It will be 0.2 degree Celsius, right? Okay, 0.2 degree ആയിരിക്കും 5 small lines ആണ് ഇതിനിടയിലുള്ളതെന്നുണ്ടെങ്കിൽ. Okay, so we have to know these small division, how these small divisions comes, or what are the value of that small divisions, right? So that we can correctly read the thermometer and we can find the actual temperature using this thermometer. Okay. So in between these larger lines, that means between 1 degrees, there are 10 small lines are there in this laboratory thermometer. In this means the given figure in your textbooks. Okay. So if you carefully note that, you can find that there are 10 small divisions in between in between two large lines. Okay. So that is how to find the value of one small unit. Okay. And there is an activity given to you. Take some tap water in a beaker or a mug. Dip the thermometer in water so that the bulb is immersed in water but does not touch the bottom or the sides of the container. So you have to place the thermometer carefully. The thermometer should not touch the container. Okay. So you have to dip the thermometer in water so that the bulb is immersed in water but does not touch the bottom or the sides of the container. And hold the thermometer vertically. Observe the movement of mercury in the thermometer. Okay. Wait the mercury then becomes steady. So we take some tap water and place this thermometer inside that so that the bulb does not touch the container. Okay. If the bulb touch the container, means the thermometer will read the temperature of that container also. Okay. So we cannot get the actual temperature of the water inside that beaker. Okay. So if you want to take the actual temperature of that water only, you have to place the thermometer carefully. That means the bulb does not touch the container. Okay. So we can find the mercury level will increase. Okay. So before dipping that the thermometer in the water, you have to note that the mercury level should be low, okay, below the minus 10 degree, okay. And after that you can place that thermometer inside the water, okay. So we can see the mercury thread will move upward, okay, and after some time it will become steady, and that steady level you can see the scale. And if suppose this is the beaker and you take up to here, you take water up to here and place the thermometer like this, okay, okay. So this bulb will not touch this container, okay. And after some time you can see the mercury thread, suppose it will read this is somewhat, but it is a 38 degree, like that, any value, that is how hotter, how cooler this water will indicated by this reading, okay. So the mercury thread or the mercury level becomes steady after some time, and you can measure the value of the temperature, okay. So that temperature will give the temperature of this water inside this beaker, okay. So that is how to measure the temperature of this water using this laboratory thermometer. And if suppose if somewhere the mercury thread or mercury level falls in between, this is 38 and this is 39, in between this the third line or fourth or fifth, any line, that is if it is in third line, what will be the value? It will be 38 plus this 0.1 and this 0.1, this 0.1, that means 0.3. So it will be 38.3 degrees centigrade, okay. So we have to know what are the values of each small divisions so that we can report the temperature, okay. So that will be the temperature of that water inside the beaker, okay. So after noting the reading, we will take the thermometer outside, and you can see the mercury level fall back rapidly. When you place the thermometer inside the beaker, gradually the mercury level increases or moves upward, and it will take a steady level, that is the temperature of that water. And after noting that reading, you will take the thermometer out, right? And rapidly the mercury level falls down. In the case of clinical thermometer, what we do? Yeah, we place the thermometer below our tank, just below our tank. After some time, we will take it out and note that reading, right? But here we cannot take out the thermometer and note that reading. When we take out the thermometer, what will happen? Immediately the mercury level falls down, okay. So we cannot note that reading after taking the thermometer from that water. We have to find or we have to note the reading when the thermometer dip inside the water, okay. So that is the main difference between clinical thermometer and laboratory thermometer, okay. So that is how to measure the temperature using a laboratory thermometer. And you have an activity. And also, in addition to the precautions to be taken while reading the clinical thermometer, the laboratory thermometer, you should keep the thermometer upright, not fitted. That means the thermometer should not touch the container, and the thermometer should be placed vertical, okay. That means it should be kept upright, not tilted, not to be tilted or sliding like that. any tilt or shake will not give the correct measurement, right? So it should be kept upright, and bulb should not be surrounded from all the sides by the substance which the temperature is to be measured. Sorry, bulb should be surrounded from all sides by the temperature of which that temperature is to be measured. The bulb should not touch the surface of the container. So, all other precautions while we taking the clinical thermometer, we have to use it carefully, and it will not make any. The mercury is a harm substance. Here also in that bulb, mercury is filled in the bulb. Okay, so handle with care. Will not hold the thermometer by its bulb. Okay, so all that precautions should be followed here also. But instead of these precautions, we have to kept the thermometer upright, not to be tilted. Okay, and one more thing, but the substance should be surrounded from all sides of that bulb. Okay, ബൾബിൻ്റെ എല്ലാ സൈഡിലും നമ്മൾ ഏത് സബ്സ്റ്റൻസിൻ്റെ ടെമ്പറേച്ചറാണോ മെഷർ ചെയ്യുന്നത് ആ സബ്സ്റ്റൻസ് ഫുള്ളി കവേർഡ് ആയിരിക്കണം. ഓക്കെ, സോ ദാറ്റ് ദ ബൾബ് ദ മെർക്കുറി will rise up and give the actual temperature. Okay, and one more thing, the bulb should not touch the surface where we kept the substance. Okay, so these two things should be taken in care. Okay, and activity 4.5, take some hot water in a beaker or a mug, dip the thermometer in water, wait till the mercury thread become steady and note the temperature. Now take up the thermometer from water, observe carefully what happens now. What happens now? Yeah, we already said that the mercury level will fall down rapidly. Okay, and do you notice that as soon as you take the thermometer out water, the level of mercury begin to fall. Okay, this means the temperature must be read while the thermometer is in water, right? So if you want to know the temperature of the water, you have to keep the thermometer inside that water. Okay, so that is the main difference between clinical thermometer and laboratory thermometer. And why do the mercury not fall or rise in a clinical thermometer when taken out from our mouth, or we used to measure the clinical thermometer by temperature by clinical thermometer by holding it just below the tongue and after some time taking it outside, right? Why it measure, or why the mercury level did not fall immediately just like a laboratory thermometer? Yeah, if you observe a clinical thermometer carefully, you can see a kink, that means a light curl or bend in that. Clinical thermometer has a kink in it. That means the mercury thread is somewhat the bulb just above that bulb. You can see in your textbooks figure 4.6, a clinical thermometer has a kink in it. That means a light curl or bend just above that bulb. Okay, so due to this kink, what happens? The mercury level will not fall down rapidly or will not rise above rapidly. Okay, so it will take some time. Okay, so the laboratory thermometer does not have that much of or that kind of a kink. Okay, so that is how the mercury falls rapidly, or in a clinical thermometer it has a kink, and due to that kink the mercury level will not fall down immediately or rapidly. Okay, so that is how laboratory thermometer differ from clinical thermometer. Okay, so there is a lot of concern over the use of mercury in thermometer. Mercury is a toxic substance and is very difficult to dispose of if a thermometer breaks. And these days, digital thermometers are available which do not use mercury. So, we already know we have to handle the thermometer carefully, and mercury is a harmful substance, right? So, if the thermometer breaks down, we have to dispose that mercury, right? Inside that bulb, mercury is filled, right? So we have to dispose that mercury. It is a tedious process, right? So nowadays we use digital thermometers that will not need any help of this mercury. Okay. So you can see anywhere in this corona season, you can see anywhere is digital thermometers, right? That can measure our body temperature as well as temperature of some other objects. Okay. So that is about thermometers. Okay. So now we are going to discuss how the heat is transferred from one point to another. So heat transfer methods. Now we are going to discuss about heat transfer methods. Okay. So transfer of heat. So how heat transfer from one point to another? You might have observed that fry pan becomes hot when kept on a flame. Okay, so fry pan or any the utensils, the kitchen utensils you put on a stove. What happens when it lights? Then it will hot. It will become hot after some time, right? So it is because the heat passes from the flame to the utensil, right? From that stove, the heat transfer from that flame to that utensil, right? Because of this heat transfer, the utensil will become hot. Okay. So when a pan is removed from the fire, it slowly cools down. Okay. These are things we are experiencing in our day-to-day life. Okay. So when does it cool down, or the heat is transferred from the pan to the surroundings? That means when we kept the pan or fry pan above the stove, it become hot, right? And after switch off the stove, after off the stove, then we kept the pan in when we kept the pan outside. What happens after some time? It will cool its own, right? So what happens there? The heat from that pan moves in that surroundings, and it will cool gradually. Okay. So you can understand that in both cases the heat flows from a hotter object to a colder object. That means in first case, the fire from that stove or flame, the heat from that flame pass to the pan. That means when we kept that pan, at that time the pan is not hot, right? And after some time it will become hot, right? So that is, the flame is hotter, and this heat will transfer to the cold pan. Okay. So in the second case, when we switch off that flame, what happens? The hotter pan will become cool gradually. That means that heat transfer from the pan to the surrounding. That means when comparing that pan, the surroundings are cool, right? So from that hot body, the heat transfer from that hot body to the surrounding that are cool. Okay. So In all the cases, hot objects, the heat flows from the hot objects to cold objects. In fact, in all cases, heat flows from a hotter object to a colder object, right? So heat always transfer from a hot object to cold object. Okay. So always heat transfer from a hot object to cold object. Okay. So how does this heat transfer? What are the ways of heat transferring? Then we have to study. There are three ways of transferring heat. That means transfer of heat may be due to conduction, or it may be due to convection, or it may be due to radiation. Okay. So these are the three ways of heat transfer. Okay. So we have to study each of these terms. Okay. So first of all, we can see what is conduction. Okay. What is conduction? And before going to that, you have an activity. This activity will show you how conduction happens. Okay. Normally, conduction happens through solids. In solids, the heat transfer occurs by the process conduction. Okay. So, it is the conduction, the heat transfer from solids by the method conduction. Okay. So, look into the activity 4.6. Take a rod or flat strip of metal. Take a rod or a flat strip of metal, say of aluminium or iron. Okay. And fix a few small wax pieces on the rod. Okay. And these pieces should be at nearly equal distance. So you just take a flat strip of aluminium or a iron and fix few small wax pieces on the rod. And these pieces should be at nearly equal distance. And clamp the rod to a stand. If you do not find a stand, you can put the one end of the rod in between bricks. Now heat the other end of the rod and observe. So you can just do the activity as it is given in your textbooks. Figure 4.7. 2 bricks are taken, and in between that bricks you can fix that metal rod that is fixed with small pieces of wax. Okay. So now you just heat that another end of that metal with a candle or with any heat source. Okay. And what happens to the wax pieces when we heat one end of the rod? Yeah, what happens? It will fall down. These pieces begin to fall down. That means the wax pieces begin to fall down when it becomes hot, right? When the rod becomes hotter, what happens? The wax pieces begins to fall down. Okay. And which piece of wax fall down first? Yeah, it is we can understand what happens to the wax pieces. It will fall down, and which wax piece fall down first? Yeah, the immediately after that fire or that candle, right? That means the heat is more to that piece that is near to that candle. Okay. So when we look into that iron core or iron rod or aluminium rod, what we can see, the wax pieces very near to the candle will fall down first, and then the next wax piece, and the distance become higher from the candle. What happens? Then it will fall slowly, right? Okay, so the heat is transferred from the end nearest to the flame to the other end. Okay, so if you take, this is the rod, and here we have a candle flame, and the wax pieces near to this candle will fall down first, and after this piece, and after this, like this. Okay, so the heat from here to here, heat moves from here to here. So when the heat comes from here to here, what happens? This also fall down. Okay, so the heat transfer from one end to another end, right? So this process by which the heat is transferring from one hotter end to the colder end is known as conduction. Okay, so conduction happens in metals or in solid materials, right? That means it needs this to transfer the heat from here to here. This solid material, you can see it by just an example. Like here we have a ball, and this ball have to this ball should be taken from here to here. So we need the help of some. Here a boy is standing here, and here also another boy is standing here. So this ball should be transferred from here to here. That means this first boy to this second boy. So we need the help of many other people to handle this ball from here to here. That means they need another person. Then he will give this ball to here, and this person will give to another person, and this is go like this. And after some more people, at last it will reach to this boy. Okay. So like that, the heat transfer from one end, that is here the metal particle or the iron rod have some particle here, and this particle will heat it up first, and this heat will given to another particle, and it will given to another particle, and then it will given to another, and like that this heat will exchange one particle to another, like that. Okay, so conduction happen in solid, so that in solids there are so many particles are in solid. You can you have to study about solid, liquid and gases. I think it will, the detailed study of these matters will be given to you in your higher classes, right? So just know solid have particles that are closely packed inside. Okay, like this. And if this is solid, okay, here also, that is the particles of solid are closely packed. And if we comes to water or liquid, what happens? Yeah, the particles have some space in between them. Okay, and if you come to what gases, these distance are more. Okay, so in between these constituent particles there are some voids or some free spaces are there. In the case of gases, this space will become more. Okay. So in the case of solid, the particles are closely packed. So when we heat this end, what happens? This particle heated up, and it will give the heat to this particle, and immediately the heat will transfer to the whole particles, right? So that solid particle will become hot after some time, right? So that is how the conduction happens. Okay, that is how the conduction happens. So the transfer of heat from one point to another point through these constituent particles, that is solid have the particles and it will transfer heat from one point to another. Okay, so that is how the conduction happens. And do all the substance conduct heat easily? All the substance will not conduct heat easily. Okay. So here in this activity we said that you have to take a metal piece or a metal strip like aluminium or iron. You will not take a wooden piece or wooden rod or a plastic rod. Okay, you cannot find or you cannot get this much of what this kind of result when if you take a wooden rod or a plastic rod. Okay, so the result will be different. Okay, so the materials or the substance conduct heat will will be different. Okay, so you must have observed that a metallic pan for cooking has a plastic or a wooden handle. That means a plastic or wood will not conduct heat as in the case of metal. That means the utensils, the cooking utensils may be have what aluminium or what copper or iron like that. Okay, so these metals will conduct heat rapidly, but the pans have what wooden handle or plastic handle. That plastic or wood will not conduct heat that much easily. Okay, so that handles will not become very hot as in the case of that utensil. Okay, അപ്പോൾ നമ്മൾ യൂട്ടൻസിൽസ് ഹീറ്റ് ആവുന്ന അത്ര സ്പീഡിൽ അതിൻ്റെ ഹാൻഡിൽസ് ഹീറ്റ് ആവില്ല, ബിക്കോസ് the substance that is the handle is made up of plastic or wood, right? So that plastic or wood will not conduct heat that much easily. Okay, so in the activity 4.7 you have to find the difference between these materials, how the materials or substance conduct heat. Okay, so heat water in a small pan or beaker and collect some articles such as steel spoon, a plastic scale, pencil and divider. Dip one end of each of these articles in hot water. Wait for a few minutes. Touch the other end of these things, other end, enter your observation. So you can find that the steel spoon become more hot. That means it's made up of metal, right? And you will feel the pencil or the plastic scale will not become that much hotter. Okay, that means this wood and plastic will not conduct heat that much easily. And in the case of this divider has a plastic end, right? So that also that feels some hot, but not that much in the case of a steel spoon. Okay, so you have to write the observations here. This experiments you can do in your homes, right? So you have to do that experiment and you have to write the observation in your table 4.3, that is in page number 41. Article it is given that one example is given to you, a steel spoon and material with which the article is made, that is steel spoon is made up of steel, that is steel is a metal, right? Okay, and do the other end get hot, yes or no? So the steel spoon will get hot. Okay, and you have to write here the pencil and a plastic scale and divider. All these things you have to write in article, and material in which the article is made also you can find. That is, pencil is made up of wood and scale is made up of plastic, and divider is also made up of metal, but the divider has it as another end with a plastic coating, right? So you have to note the observations in the third box. Okay. So the materials which allow heat to pass through them easily are known as conductors. Okay. So we have to know what are conductors and insulators. Okay. So conductors means the materials which allow heat to pass through them easily are known as conductors. Okay, so you should underline that the materials which allow heat to pass through them easily are conductors of heat. That means they are known as conductors. Okay, for example, metals like aluminium, iron and copper are examples of conductors. So conductors, what they do? They allow heat to pass through them. Okay. And examples, what are the examples? All metals are examples of conductors. So metals like aluminium, copper, iron are example of conductors. So these things or these materials allow heat to pass through them. Okay, and the materials that will not allow the heat to pass through them are known as insulators. Insulators will not allow heat to pass through them. Okay, these conductors allow heat to pass through them. Okay, and insulators will not allow heat to pass through them. So, what are the examples of insulators? Yeah, these plastics, wood, like that. Okay, so these are examples of insulators. Plastic, wood and sand, like that. Okay, so these are insulators. So you have to underline what are conductors. That means the materials which allow heat to pass through them are known as conductors, and examples of conductors are also given in your textbooks. Iron, aluminium and copper are examples of conductors. And the materials which do not allow heat to pass through them easily are poor conductors of heat, such as plastic, wood are poor conductors of heat. That means they will not allow heat to pass through them easily, right? They will pass the heat from one point to another, and it will take long time, right? It will take more time. Okay, so these are poor conductors of heat, or we can say they are insulators. Okay, so in between these conductors and insulators, we have a semiconductor classification that you will study in higher classes, right? So now you just understood what is conductors and what are insulators. Okay, so conductors are the substance that allow heat to pass through them easily, right? And insulators will not allow the heat to pass through them easily. Okay, so that is about conductors and insulators. Okay, so hope you understand what is conduction and what is conductors and what are insulators. Okay, so that is about conduction, and we have to study what are convection and what are radiation. That we will study in the next class. Okay. So now we can wind up this conduction. Okay. So hope you understand, and you should study it well, and you have to read the textbooks thoroughly. Okay. So that you can get the idea about these things clearly. Okay. So we can meet in the next class, children. If you have any doubt, you can ask me anytime. Okay. So take care and thank you.